Hey guys, Mr. McKinney here with the second part of our definite integrals video series. So this one's a little bit more complicated because we've got a square root in it, and that's not an obvious, not only is it a square root, but it's the square root of x squared. So for some people you may recognize what this graph looks like right off the bat, but most of you guys are going to be a little bit puzzled. So we want to know the area between 3 and 7 of the square root of 4 minus x minus 5 squared plus 3. Now some of you guys are going to jump and graph this in Desmos, and that's a great idea, but this might show up on the non-calculator portion of the AP exam. So let's figure out how we would graph this without a calculator. So we've got the equation y equals the square root of 4 minus x minus 5 squared plus 3. Now, in order to graph this, what I'm going to do is I'm going to subtract the 3 and try to make it look like a form that I recognize from pre-cal. Then I can square both sides, so y minus 3 squared equals 4 minus x minus 5 squared, and then I can add this term over to the other side. So we've got x minus 5 squared plus y minus 3 squared equals 4. Now this hopefully looks a little bit more familiar. This is a circle formula. So if you think back to geometry or pre-cal, if you have a formula that's x minus h squared plus y minus k squared equals the radius squared, then your center is at h and k, and then your radius is basically the square root of whatever number you have on that side, so r. So in this case, we have a circle where the center is 5, 3, and the radius is 2. Now, I misspoke a little bit. This is a circle formula, but we're not dealing with the circle formula. We're dealing with this version of the circle formula. And if you think about it, a circle is not a function. It does not pass the vertical line test. But if we only look at half of the circle, either the top half or the bottom half, those are functions. Those pass the vertical line test. So since I have the positive square root here, I have the top half of a circle. So we've got the top half of a semicircle here. So let's graph it. The center is at 5, 3. And then we've got a radius of 2. So 2, 2, 2. And then we've got our semicircle. Radius is 2. Whoops. Radius is 2. Now this problem worked out nicely, and usually on this type they will, where 3 and 7 are the endpoints of this semicircle. If this problem had been exactly the same, but going from 4 to 6, we would not have had the ability to do that without a calculator. So we're able to do this one without a calculator because we have the endpoints of the semicircle. So if I want to know the value of this integral, remember that it's the area underneath the curve. So the first mistake that kids would make is that they would only calculate the area of the semicircle. That's under the curve. Now that is under the curve, but we've really got that semicircle sitting on top of a rectangle. So when I find the area, we're going to need to do a rectangle plus a semicircle. So the area of the rectangle is just length times width. A semicircle is half of a circle, so 1/2 pi r squared. For this particular rectangle, the length is 4 and the width is 3, because I know that my center is at 5, 3, so the y value is 3, and so we've got 4 by 3. And then, as mentioned earlier, the square root of this side is where I got my radius, so 1/2 times pi times 2 squared. So my area would be 12 plus 4 divided by 2 is 2 pi. So the value of this integral is 12 plus 2 pi. And you're going to need exact values when you're doing your math Excels and things like that. All right, so here's another word problem example. A particle moves with a velocity in centimeters per hour modeled by this equation, 2t plus 6, for any positive time. How far, so that's asking for distance, has the particle moved from hour 10 to hour 20? So basically we would want to take the integral from 10 to 20 of v of t dt. So from t equals 10 to t equals 20. And we're going to find the area underneath that curve. And that'll tell us the distance that it traveled during that time. In this case, you can either use the trapezoid formula or you can do a rectangle plus a triangle. So either way will give you the same answer. You can either do a rectangle plus a triangle, or it's a trapezoid. If you do it as a trapezoid, remember that your bases are always parallel to each other. So these are the two bases, and then this is the height going in between. Sorry about these random lines. I'm not sure what's going on with that. So let's work this one out real quick. And again, this is where you're going to want to plug in your t values. So v of 10, this point right here. So 20 plus 6 would be 26. V of 20, this point up here, would be 40 plus 6 is 46. So if I'm going to use the trapezoid formula, since we haven't done that one yet, 1/2 times b1 plus b2 times the height. In this case, the height is in between those two, so my height would be 10. These y values, the 26 and the 46, essentially become my bases. So the area would be 1/2 times 26 plus 46 times the height is 10. And if we work that all the way out, we should get a value, I don't remember off the top of my head. Okay, let's do some math real quick. 52, 72, half of that is 36 times 10. Should be 360. So 360, and again, it would be centimeters because we've multiplied centimeters per hour times hours. All right. Here's some whiteboard practice. So go ahead and hit pause and then try to work these out, and then we'll check our answers in a second. All right, let's see how we did. So this first one would end up just looking like a rectangle. So you'd get a value of 36. The second one would end up being a trapezoid. So you can either do a triangle plus a rectangle or use the trapezoid formula. You should get 21. This last one ends up being the top half of a semicircle with a center of 5, 0 and a radius of 5. So you get 25/2 pi. All right. We'll do one more example. It's a little bit more abstract. So we're doing the integral from a to 9b of 2x dx. Now, we're given that 0 is less than a is less than 9b. So this value is lower than this value, but they're both positive. So let's graph 2x. 2x would go through the origin and have a slope of 2. And then we're going from a to b, to 9b. We don't know what a and b are. It doesn't matter because this problem isn't asking for a number answer. We're trying to come up with an expression to answer it. Now, I've created a trapezoid here. So I need to figure out the area underneath this trapezoid between a and 9b. Now this is where I like to figure out my y values. So if I plug in a, the y value would be 2a, and then if I plug in 9b, the y value would be 18b. So this point up here is the point 9b, 18b, and this point is the point a, 2a. Knowing the y values of those points makes it easier when you're trying to figure out the area. So again, this is a trapezoid. So the formula for area of a trapezoid is 1/2 times b1 plus b2 times the height. b1 and b2 are the heights, or sorry, the y values that correspond to these 2 points. So B1, I'm going to call 2A. B2, the second base, I'm going to call 18B. And then the height is the distance between the 2 bases. That's my height for the trapezoid. So I would do 9B minus A. Now let's see if we can simplify this a little bit. So I'm going to do half of 2A plus 18B, which would just be A plus 9B times 9B minus A. Now technically you could stop here and that would be fine, but on the AP exam it would likely be a multiple choice question and it would be simplified. Now this is very close to the difference of squares formula. If I just switch this one around, 9B plus A, because if things are added you can switch the order, times 9B minus A would be 81B squared minus A squared. So this definite integral would be 81B squared minus A squared. All right, so that's where we're going to take a break for this video, and then we'll do one more video on the properties. Hopefully I'll be able to get that all in one video. Hope this is helping.